Now, if we are to consider this figure, how many significant figures does this figure have? 1, 2, 3, 4, 5, 6, 7, 8. Now, the figure has 8 digits. Does that mean that it has 8 significant figures? The figure has a decimal point. What is the significance of this decimal point? Now, we have 0.0050600. The figure has leading zeros, it has trailing zeros, and it has a zero coming between two non-zero digits, 5 and 6. Are leading zeros considered significant or not? Are trailing zeros considered significant or not? And under what condition are trailing zeros considered significant or otherwise? Now, to answer these questions, let's get ourselves familiar with these simple rules. Now, first of all, non-zero digits are considered significant figures. And secondly, whether a zero is significant or not depends on the status of the zero. Now, leading zeros, as we have here, are not significant. Their presence over here only helps to locate the decimal point. And so leading zeros are considered not significant. Now, when a zero comes in between two non-zero digits, they are considered significant. And with trailing zeros, it depends whether the figure has a decimal point. When the figure has a decimal point, trailing zeros are considered significant. When the figure does not have a decimal point, trailing zeros are considered not significant. Now, let's look at these figures. Now, the figure 149 has 3 non-zero digits. And as a rule, all non-zero digits are significant. So 149 has 3 significant figures. Now, 1358 has 4 significant figures. It has 4 non-zero digits. Now, with 1.047, we have 3 non-zero digits and a 0 in here. Now, when the 0 comes in between 2 non-zero digits, it makes it significant. So we have 4 significant figures over here. Now, this 0 is coming between 2 non-zero digits. And the status of the 0, when it comes between 2 non-zero digits, makes it significant. So 507 has 3 significant figures. Now, we have 0.00087. Now, leading numbers are not considered to be significant, because here the assumption is that they are only there to help locate the decimal point. So they are not significant. So this figure has only 2 significant digits, 8 and 7. 0.00087 has 2 significant figures. Leading zeros are not significant. So here 0.00673 has only 3 significant figures. Just as we have these leading zeros over here for this figure. Leading zeros are not considered to be significant. We have 50000. Now, this figure has 4 trailing zeros. Now, the status of trailing zeros are not significant. So all these 4 trailing zeros are not significant. So we have only 1 significant figure. Now, 6600 has 2 trailing zeros over here. Trailing zeros are not significant. So we have 2 significant figures for this number. Now, with 50.000, we would have to take note that there are also trailing zeros over here. But we should take note that once the figure contains a decimal point, it changes the status of the zeros and makes them significant. so 50.000 has 5 significant figures. Because here the assumption is that if the zeros were not to be significant, it wouldn't have been there in the first place. But once there is a decimal point in the figure, it makes the trailing zeros also significant. And so 5 significant figures. Now we have 6.600. Now, these trailing zeros over here are significant because of the decimal point. Without the decimal point in this figure, these trailing zeros would have been considered not significant, but because of the decimal point, the assumption is that it wouldn't have been there if it were not to be significant. And so 6.600 has 4 significant figures. Now we have 0.005, 0000. We have 3 leading zeros over here and 4 trailing zeros over here. But with trailing zeros, it depends whether there is a decimal point in the figure or not. Once there is a decimal point, trailing zeros are considered to be significant. And so for this value, 0.005, 0000 has 5 significant figures. Now 0.06600 has 2 leading zeros and 2 trailing zeros. Now leading zeros are non-significant. Trailing zeros of a number are also non-significant, but when there is a decimal point in the number, trailing zeros become significant. And so this number has 4 significant figures. So the determination of significant figures for a figure are quite very simple. Non-zero digits are significant. Whether a zero is a significant figure or not depends on the status of the zero. When it comes between 2 non-zero digits, it is considered to be significant. Zeros leading a number are considered to be non-significant. Trailing zeros are considered to be non-significant. However, when there is a decimal point in the figure, the status of trailing zeros changes and becomes significant. So these are a few exercises. Let's familiarize ourselves with these rules. Now, let's turn our attention to how to round up figures. Now, if we have the number and we have to round this number to 5 significant figures, what will be our answer? Now, this number has 7 significant figures. So to round it up to 5 significant figures, it would require that we remove these 2 digits. So we would have these 5 figures to round up. Now, this is the first digit of the digits to be removed. Now, if this first to be removed is 5 or more, then we are going to add 1 to the digits to the left. And when we add 1 to 7, we are going to get 8. So in rounding up this figure to 5 significant figures, we're going to have 188.38. That is figure rounded up to 5 significant figures. Now, let's look at these figures. Now, what is this figure rounded up to 3 significant figures? Now, 2.304 has 4 significant figures. And so if we are to round up to 3 significant figures, we need to remove this digit. But since the digit is 4, we are going to drop it. And to 3 significant figures, we are going to have 2.30. That is rounded up to 3 significant figures. Now, how do we round 0.00887 to 1 significant figure? This number has 3 significant figures. And so to round it up to 1 significant figure, we need to remove these 2 digits. But the first digit to be removed is more than 5. It is greater than 5. And so when it so happens, we're going to round up the figure by adding 1 to the digit left to it. And so we're going to have 0.009. That is rounding up to 1 significant figure. Now we are rounding this number to 4 significant figures. This figure has 6 significant figures. We shouldn't forget that zeros that come in between 2 non-zero digits are considered significant. So to round this number to 4 significant figures would mean that we would have to remove these 2 digits. The first digit to be removed is 3. It is less than 4. So we are going to drop this digit and the following one. So in rounding up this figure to 4 significant figures, we're going to have, that is rounded up to 4 significant figures. Now, basically, if the first number to be removed is 5 or more, it is converted to 1 and added to the number to the left. And when the first number to be removed is 4 or less, that number is dropped. Now, in carrying out addition or subtraction, how do we decide how many digits to keep? So, for example, if we have now for this first one, rewriting it, we align the decimal points. Now, for convenience, we can fill the space with the 0 and have as our answer. Now, our answer should be kept in the least number of digits after the decimal point as the original numbers. Now, 88.80 has 2 digits after the decimal point. 7.391 has 3 digits after the decimal point. So we're going to leave our answer in the least number of digits after the decimal point. So our answer will be 96.19. Now, for the second one, now 124 has an implied decimal point. So we're going to align our decimal points. Now, for convenience, let's fill the spaces. So we're going to have now 124 has no digits after the decimal point, and this figure has 3 digits after the decimal point. So we're going to leave our answer with no digits after the decimal point. So that will mean that we have to remove these digits. But in doing so, the first digit to be removed is more than 5. So we're going to add 1 to the digit on its left. And we're going to have as our answer 126. Now, with the last one, let's align the decimal points. Now, this one has 3 digits after the decimal point. 7.4 has 1 digit after the decimal point. So we're going to make sure that we leave our final answer at 1 digit after the decimal point. Now, with 1 digit after the decimal point means we have to remove this 2 digits and present our answer as 11.9. So in carrying out subtraction or addition, our final answer should be left in the least number of decimal points as their original numbers have. Now, in carrying out division or multiplication, for example, if we are to have (18) has 2 significant figures. 13.75 has 4 significant figures. And so we're going to leave our answer in the least number of significant figures as their original numbers. So when we do the math for this one, we're going to have now our answer has 8 significant figures, but 18 has the least number of significant figures. So we need to remove these digits in order to keep our answer 2 significant figures, determined by the least number of significant figures as their original numbers. So our answer is 0.76. Now 3.465 has 4 significant figures. 0.023 has 2 significant figures. And here again, this number has the least number of significant figures, and so our answer should be left in 2 significant figures. Now when we do the math, we're going to get, so we need to remove this number of digits, but the first digit to be removed is greater than 5, and when it so happens, we're going to add 1 to the digit to its left. So we're going to have as our answer 0.080. In carrying out division or multiplication, the number of significant figures that our answer should have is determined by the least number of significant figures as our original numbers. So this is the end of my video. Thank you very much for watching, but keep watching.